It's been said that the best way to predict the future is to create it. For over 50 years, SAIC has embraced the unknown. Mission focused to build a tomorrow that works for everyone. Bold transformations, digital ingenuity, the explosive, thrillingly awesome power of tech. That's what inspires us. So no matter what the future holds, we're ready to bring on tomorrow.
Welcome back, everybody. Hopefully everybody got to say hi to some folks and get some beverages and some snacks. So let's get right back into it with our next session, Commercial LEO Destinations. This session is brought to you by our all-day sponsors, Boeing and SAIC, as well as Blue Origin. Thank you very much to all of you for your support. So I'd like to introduce Angela Hart. Angela is the program manager for NASA Johnson's Commercial LEO Development Program. Angela, take it away.
All right, thank you. First, I want to thank everyone for being here and listening to this panel. Something that everybody here up on stage is very invested and excited about, and I hope that comes across when we talk a little bit today. So as the mentioned, I'm the program manager for Commercial LEO Development Program at JSC. It's a relatively new program, about 2 years old, really instituted for SOMD to develop a place for us to bring together all of the activities that we were doing to instill commercialization in LEO, and predominantly, as we'll talk about today, to enable and partner with the industry to develop the next commercial LEO destinations that we will need once ISS has its end of life. So we've been working this vision of a robust economy in low Earth orbit for a while. It started on ISS. ISS is still doing a number of things today, and my program is working with them on a number of activities, including the private astronaut missions, other commercial activities on ISS. And we continue to look for more and more items that we can do to utilize that platform to help and build this industry and this economy that we need in order to be successful in a commercial LEO economy where NASA is one of many customers. So as I mentioned, we are partnering with industry to commercially develop commercially owned and operated LEO destinations. We need them to be safe, reliable, cost-effective, but allow NASA to be able to purchase services. We're following on the footsteps of our CRS and CCP models, doing a very similar approach that we saw in those developments with a little bit different tweak that I'll talk about just in a minute. In phase one, that's the development phase. We're working with industry, and we'll talk about my phase one partners today. And then in phase two, we'll go into that certification and services phase where we will purchase services and human rate these vehicles for NASA's ability to continue US and other continuous human presence in LEO. In phase one, as I mentioned, NASA's partnered with 4 commercial destination providers. The first, Axiom Space, was awarded a contract in 2020 to utilize a port on the ISS to develop a platform that would ultimately have the opportunity to leave ISS and become a free-flying destination able to provide us services post-ISS. We then went out with funded Space Act agreements for the free flyer ability to build a destination. When NASA was developing how do we get to a commercial LEO destination back when ISS was imagining this before a commercial LEO development program existed, we really thought there were two ways to get there, right? First would be potentially to start on ISS and then move out and become a free flyer. And the second is just to build directly as a free flying platform. In 2021, NASA partnered with Blue Origin, Northrop Grumman, and Nanoracks to utilize funded Space Act agreements to help them in their endeavors to move forward with commercial LEO destinations. So with that, I really want to introduce the three panelists we have today. Unfortunately, our Northrop Grumman panelist was not able to make it, but we have some very esteemed colleagues here. And I'll start with Lynne Dittmar. She is Axiom's Chief Government and External Relations Officer. In this role, she directs the company's government and regulatory affairs, acting as a thought leader with the U.S. government's executive and legislative branches. She also guides Axiom's outreach and external affairs teams, articulating Axiom's mission to build the world's first commercial space station and its vision to enable continuing human presence and U.S. leadership in low Earth orbit, benefiting every human everywhere. And then I appreciate the partners here allowing me to share a fun fact about them that you might not have known. Lynne has spent 30 years singing professionally in jazz and pop venues, and some of them here in Huntsville. And so another passion of hers that you may not be aware of. So thank you for being here, Lynne. Thank you. Next, I want to introduce Brent Sherwood from Blue Origin. He's the Senior Vice President, Advanced Development Programs for Blue Origin. His teams are developing in-space systems and services for human spaceflight and space infrastructure that will open space to human expansion. Brent is a space architect with over 35 years in the business at Boeing, JPL, and now Blue Origin. He is a former member of the AAS board. And a fun fact about Brent that I thought was really interesting is he has been envisioning really CLD since 1991. He wrote the first paper on the modern era potential destination about resort hotels in space. The prior one was written by Baron Hilton's conference talk in the 1970s. And so based on that, Chuck Lauer and he developed and published the mixed-use space business park concept in the early 90s. And I'm sure he's extremely excited to be able to see that vision starting to take shape today. And last but not least is Marshall Smith with Voyager Space. Marshall joined Voyager Space in October 2022 as the Vice President for Exploration, bringing 30 years plus of extensive experience in human-rated space systems. Marshall directed large integrated teams to develop and implement some of NASA's most critical human spaceflight architecture, including systems engineering for SLS, Orion, and exploration ground systems before retiring and joining the Nanoracks team and then moving on to the Voyager team. Marshall oversees the development of Voyager's customer-focused commercial space stations, lunar platforms, and additional supporting systems. And fun fact about Marshall, which we'll see if this works out, he loves to ski and travel, and being that they have some partners in Denver, maybe we'll get to see that happen. Good work. So as I said, Mitran from Northrop Grumman was going to join us, but unfortunately he was not able to because of illness. So we're really sorry to not have him here today, but we'll manage to move on without him. So with that, what I'd like to do is I'm going to turn it over to each panelist. They're going to give you a little information about each of their architectures and their overall vision, and then we'll move into a question and answer period. So I'll start with you, Lynne.
Okay, thanks, Angela, and thanks for the introduction. Hello to everybody. Thanks to AAS for the invitation. It is always fun for me to be back in Huntsville. Some people don't know I was on faculty here from 1989 to 1995 when I left to start a company, first of 4. And I also have spent a lot of time here. Basically, I worked for Boeing here, starting on it was a R&D group, actually an internal think tank inside Boeing. And so I have a lot of fond memories of Huntsville. So it's great to be here. I spent a lot of my early days in space out at the Marshall Space Flight Center. So I'm going to talk just a little bit about Axiom's approach. Angela's already made some reference to it. It's a little different than the other CLD folks that are engaged in this. Axiom was actually founded in 2016 with the idea of building a commercial space station. It was co-founded by the former ISS program manager, who many of you know here, Mike Suffredini. And then his co-founder is Dr. Cam Ghaffarian, who founded SGT, which at one point was the second largest provider of engineering services to NASA, including providing services to the ISS program. And so the two of them had a lot of sort of insight about ISS, and Mike had spent a lot of time thinking about what he would do differently if he had the chance to go about doing things differently. So they co-founded that company in 2016. In 2019, they actually started to do preparations to fly private astronaut missions. That was actually before it became a real sort of procurement, but they began working on that, but brought Mike LA in. After he retired from NASA, he was an experienced ISS commander, and not too long after that, brought in Peggy Whitson, who is very, very experienced, as you all know, NASA astronaut and former ISS commander. And then in 2020, competed to win in a full and open competition to win access to the port on the ISS, which is an exclusive, basically, award that came along with a contract. And the contract essentially is a data buy. And so the contract basically pays Axiom to develop data and then develop that and deliver it to NASA in work packages under a series of task orders as they're developing this, as we're developing the station. So the current plan for the station is for it to launch its first module, which is actually under development right now. All of the pieces of the shell of the module have actually been built. They're all fabricated. They're in the process of being assembled at Tazi Alenia in Torino, Italy. Tazi was responsible, it's Thales Alenia Space Industries. Tazi is responsible for building about 40% of the structure of the ISS, as well as manufacturing the Cygnus module that several people know about with Northrop Grumman. And so they're actually developing that module. It's in the process of being put together right now. I got very excited when I saw 4 pieces of the bulkhead all welded together looking like an actual module, because I was on the station program here at Marshall when all 5 of, only 4 of which flew, 5 of what became the US segment were actually in one high bay building at one time. I still have photos. I see people nodding. See, you're all as old as I am. And so basically, it was real exciting to see that coming together. The first 2 modules are clones. So the first one will launch basically at the end of 2025. It will be shipped to Houston and fully outfitted there before it's then sent to the Cape to be launched. The second one launches about 6 to 8 months after that. The third one it will be essentially a redo of one of the MPLMs for the space station, the multi-purpose logistics module. And that actually will be sort of stripped down and re-outfitted, and that'll actually be the third module. That'll be a research and development lab. The first 2 modules will split between habitation and lab space. The third module is purely lab space and manufacturing capability. And then the fourth module, which will come sometime later, is what we call Power Tower. It's a service module. Up to that point, we're drawing all our services from the ISS. We may also be providing some additional services in terms of power. We're looking at all of that right now with regard to power needs in particular. But that'll launch then. And then once that attaches, in very short order after that, the entire Axiom station complex will detach from the ISS and become a free flyer. So the way we're preparing for that is first to sort of develop those modules, as I described a little bit, and then we're flying PAM missions, and we're flying private astronaut missions. We flew the first one in April of this year. We're awarded the second one, and we're preparing to fly that in May of next year. And while the astronauts themselves and the on-orbit stuff is kind of what gets a lot of the publicity, the real purpose of this is to develop joint operations with NASA. It's essentially to learn how to operate side by side with the space agency, basically get our systems to work with their systems, develop training capabilities, learn as we go about how we do need to be training commercial astronauts, and then also how we work with NASA. So the first PAM mission was operated from JSC. The second PAM mission will actually be operated from our own Mission Control Center, which has been built in Houston and will be done jointly with the JSC Mission Control Center. So those are working together. So that's how we are starting to develop those capabilities. And then the third piece of all of this is to be developing markets. And I'm not going to go a lot into that because we're going to talk more about that, I think, as we get into this. But it's working with customers to sort of explore what are those markets and how do you identify those market segments and how do you work with those. And we're doing some of that through the PAM missions, but we're doing a lot more of it outside outside the PM missions. So I think I'll stop right there. We'll go from there.
I appreciate it. Next, we'll just move down the line. So Brent, do you want to talk about yours?
Sure. So for those who maybe haven't followed recently in the news or haven't seen the data, Blue Origin's growing very rapidly. And we have a suborbital business with New Shepard, and we're closing in on first launch date for our big orbital rocket, heavy lift LEO system. And we have 5 engine product lines, all in parallel development, all reusable engines. But then there's this other business, which is mine. So if it's not an engine or a rocket, then it's advanced development programs. And we have a variety of programs for human exploration and cislunar operations. In our space destinations area, Orbital Reef is the flagship program. I think there it is. So you may have seen this since we announced it at IAC a year and a half ago, or a little less than that. It has, I'm going to say, because most of you are aerospace folks, it's got a lot of very cool features that nerds love, but we can talk about that later. The thing I really want you to know is that perhaps unlike a lot of systems traditionally, and maybe more in keeping with the description Spuds gave earlier about how NASA is developing the Artemis architecture, what we're doing is developing a technical architecture in service of a business architecture. So we aimed at a business model, which is very intentionally think of it as a landlord-tenant model, just like business parks here on Earth. And you heard Angela mention earlier, we've been thinking about mixed-use business parks for a very long time. The idea there is that what you want to do is make it as easy as possible for entrepreneurs or any type of business to operate in this new environment. So the way to do that is to there's several ways. One is to have a reusable launch system that lowers the cost so they can get up and down. But another way is to take all the really hard parts about being in space and operating in space, running a space station, flying a space station, take that off their plate and keep it in the core infrastructure, which is what you see running up the middle spine of this system architecture, to make the tenant services, the modules in which people will conduct their business, as simple as possible. And so if you think about the architecture of space station, we did sort of everything all at once. And that's why we all know what the inside of the space station looks like. And it looks that way because that's how laboratories have to be. But you don't really want to sleep in the laboratory, unless you're a grad student. And if you want mixed use, you're going to have a lot of customers, tenants, users who have nothing to do with research. This is one of the challenges that as a community we're working through, is how do you actually accommodate mixed use operations in a very high-tech environment in low Earth orbit. So one of the features of our architecture is to distill those things, to separate them out so that individual tenant functions are not in mutual conflict and are not all mixed in with the space station architecture vehicle functions. So that's why you see it look the way it does. There's a few other things I have to mention, a couple of nerd things, because we are building a big rocket. We build very large diameter things. So our modules are 7 meters in diameter, which is more than 50% bigger than traditional modules. That gives you a lot more flexibility inside. The largest windows ever developed for spaceflight are in test now. And so there are a lot of features about this space architecture that are novel. And that's really important because of some of the markets that we're all about developing up here. So we're very familiar with microgravity research, and that will continue. NASA and its peer agencies will have an ongoing, continuous need for microgravity research. And the thing that's good about that is it's a market that we all understand. The thing that's bad about that is it's a market that's not going to grow tremendously. It's not going to go up by a factor of 10 in the future, right? It's fundamental research. There's another whole sector which everybody is hopeful about, but which has yet to develop or really be tested in a meaningful way. And that's a range of industrial applications, hopeful industrial applications, products that could be made in space and sold on Earth. Not quite sure what those might be yet. And other businesses like entertainment and advertising and gaming and those kinds of things that aren't done on government laboratories in space today. And then the third sector, which is where the big windows and some of these other features come in, is people. Flying people in space is kind of the essence of human space flight, you might think. And part of our company's vision is to build the foundation that enables a future in which millions of people are living and working in space to benefit Earth. So I like to tell my team, before you can have millions, you got to have thousands. Before thousands, hundreds. Before hundreds, a few dozen. And so that's what you see in this image here. The configuration on the left is the one that'll be flying in the late 2020s, and then expanding as the market grows and as we all learn how the market can grow, and then servicing that market into the 2030s and beyond. Stop there.
Thank you very much. And Marshall?
Yeah, thanks. Actually, I love hearing Brent talk about this because, we have a similar vision, but I think we're implementing slightly differently. We look at, we'll have an image of Starlab coming up in a minute. Our goal is to not try to build everything all in one place. We're looking to actually build smaller systems that are focused on a customer's needs and needs base, so we can deliver the capability. For example, the Starlab has basically full operating capability after one launch. We might add a module, we might add 2 modules, that's it. It might be one large one and one small one, but that's probably about it. And then we're going to focus in on, allowing that station to do the job that it's going to be focused toward. The first one obviously is for the market, like Brent was talking about, that we're all know and love, which is, research, science and research. But as things move on, we might get more into entertainment. We will move more toward tourism. We'll move towards manufacturing. Nobody wants to be doing something that causes issues with their microgravity research while somebody's next door doing some kind of crazy movie where they're bouncing off the walls. These are things we want to keep separated. Our goal is to actually separate them by more than just a module. We want them to be in different orbits even. It also allows for other opportunities. There are other governments right now. The way things have been laid out is, stations have been one thing that everybody goes to, the station, or maybe in the future, maybe they go to 3 or 4 stations. But there's no reason why we can't operate stations for a country that may want to actually continuously crew it the whole time themselves, put their own experiments on it and run it the way they want to run it. So those are all options we have with the smaller approach. We've got high power. It's about 40% of we're about 40% of the size of the ISS. It's about 40% of the size of the power. It's actually got all the payload capability that the ISS has. So we're designing this one around actually accomplishing the missions. Nanoracks has spent about 13 years working on ISS. And so we've kind of look at this and how do we go give the customer what they need and what they want, because we see the interface between NASA and the customer. It's been good, but we think that there's things that we can improve on because we'll design the system from the beginning, which I'll talk about in just a second. Open architecture, we want to make sure we work with everybody. One thing's interesting about Voyager Space and Nanoracks is we're not a launch vehicle provider. We're not doing those types of things. We're not a pure giant hardware systems provider. We want to go buy competitively these services from people like Blue Origin and from SpaceX and from Sierra when Dream Chaser comes along and those types of things. So we want to actually be able to use the system, the economy that NASA has been building, and how do we now use that to provide goods and services that people want and in the way they want it. Let's go to the next chart. I think I've just got one more. So one of the key tenets of what we're doing is what's called the George Washington Carver Science Park. This is the core of the Starlab Starlab system. It is what do we do and how do we do it in space? How do we do our research? How do we lay this out? Science parks have been around on the Earth for a long time. They're very well-known institutions. researchers, science, universities, businesses know how to interface to that. It provides a capability that they can go exercise on the ground. They know what those interfaces are, and they're very common. We want to set up science parks not only on Starlab, but also we're going to be actually doing the first experiment from George Washington Science Carver, GWC, we call it for short. I'll just start saying that. The GWC Science Park on ISS next year. So we're going to look at it as a way to, we're going to use it as a way to move platforms, move systems, move experiments quickly and efficiently through the system. And then, of course, once we have our own platform, we can tune that, really fine tune that to make that much more efficient. But it is a proven business model. We have a lot of folks engaged in it. And we will have dedicated laboratories for biology, plants, a lot of agricultural work, which is where the George Washington Carver comes from. We're paying homage to a great scientist in agriculture, materials research, and just open bench work areas for commercial projects. We have a number of partners in this, which is actually one more slide, and then I think that's my last one now. Just a number of partners within that. Zen Technologies has been working on ISS for a while. USRA, as well as Ohio State and International Association of Science Parks. We're trying to bring this global. It's not just about what we're doing in the US, but how do we bring in science experiments from around the world, and how do we build that up? And then Dream Up is dealing with STEM education, and then Starlab Oasis, which is agriculture based. It's actually over in UAE. I think that's probably the big things.
Okay. So with that, you guys have actually, played the straight man to my first question, and I expected that you would. You're really seeing a unique approach from all of the partners here today on what they're envisioning this will look like. And for me, it ties into what I foresee in the long run on how we get this cost-effective, sustained economy in low Earth orbit. It's going to take all kinds and different markets and different ways of doing business, from continuously manned human space stations to unmanned vehicles to sortie missions. I think it's going to be, we're going to start seeing more and more across the gamut of opportunities for folks to build this economy. But that being said, all your architectures are unique, and all of them, to some degree, as you noted, are planning capabilities to allow NASA and others to continue the very needed research that we've been doing so successfully on the ISS. As you've been building those architectures, have you identified any key changes or barriers that you think need to be addressed by NASA and industry to ensure that we, one, maintain NASA's needs for this fundamental research and exploration, but at the same time be able to serve those other customers that we want you to have as the one-to-many customer concept? But are there any barriers or changes that you think need to be addressed? And I'd really like to hear from all three of you. So I'll just kind of let you decide who wants to go first.
All righty then. So one of the concerns I think is shared, I don't know how broadly among industry, I don't want to speak for my fellow panelists. NASA's current plan has it coming forward with requirements, needs for the agency in another few years, sort of mid-decade. We're in the process of designing and building right now. Everyone is in the process of designing and developing right now. And while on the one hand, the argument can be made that if NASA comes out with those too early, there is a concern, I think on the part of NASA, at least, and I don't want to speak for you either, that that'll drive people who are developing stations to develop them to serve NASA. And that in doing that, you may end up not being flexible enough or may not be responsive to other market demands from other customers. However, I'd like to articulate the flip side of that argument. We at Axiom are not counting on NASA as an anchor tenant. We are setting Axiom up to try to treat NASA as a preferred preferred tenant, a preferred customer, which we're doing by attaching to the space station, immediately expanding the capabilities of the space station as soon as we do so, providing literally a physical bridge to transfer research capabilities that are on board the station, and also trying to, as I mentioned before, learn how to do joint operations, like lots of different things that we're trying to do. But our concern is that if NASA comes forward with those requirements too late, then we may have the opposite problem. which is our business case does not depend upon NASA. It can't. As Brent already pointed out, it's not a growth market. And so we have to be marketing to other customers. We have to be developing other capabilities that will meet those customers. NASA's concern about this, while I understand it, is out of phase with what it is that we are doing at Axiom. And our concern is that if NASA comes forward too late with those, then we may not be able to meet the needs of NASA or the basic research community. Okay, we'll make it a point to do so, but it becomes harder to do so. Lots of other customers are happy to share their requirements with us now. We all understand, okay, that those requirements are going to continue to move. And I want to belabor this. If we were to go to NASA today and say, please put out all your requirements, I think we'd get a requirement set that would be this big. Because the agency would essentially say, okay, I've got to envelope all this. That's not great either. So this is a tough problem. It's one I'm sympathetic to. Personally, would like to see some sort of rolling means by which NASA initially says, okay, here's the initial requirement set. We'd like to work with you collaboratively to start paring this down. Okay, come up with a way that we can sort of approach this problem. And I really would urge NASA to do that.
So I was going to jump over to the others, but I'm going to go ahead and add something here because again, you kind of fed right into some of our statements. So that you absolutely put the nail on the head there with hit the nail on the head with the problem that we have. We are following that CRC-CP model, but we are in a very unique situation, and we also have a very aggressive schedule, and you are all moving out, which we are very happy about, and that's what we want to see. But there is definitely some disconnect there. We do want to make sure that we right-size those requirements, but we have laid out an approach and do absolutely intend to follow this. And you'll start seeing more and more of this coming out over the next quarters, where we are incrementally providing you our thoughts on architecture, philosophy, how we think the operations will work with NASA, what our thoughts are, so that we can continue to refine until we get to that place where I have to put pencils down and attach it to an RFP and put out phase 2. And so it's not going to be like what many folks see when we do an RFI that goes out to industry. Typically, when NASA is developing requirements, they put an RFI out, they collect it. It's kind of a one and done thing. It goes out, they bring it back, they look at what they have, they decide what they're going to incorporate, and then they put out the procurement. We are going to do this quarterly. Something is going to be coming out quarterly over the next 2 years. You will be seeing it. We put our first RFI out about 6 months ago that was really laying out what we thought the human rating requirements were going to be, what the high level headquarters requirements. Again, these are all draft documents that are going out. And it also laid out some question areas to industry on, we're thinking about this on a safety structure. What do you think about it? To get kind of feedback from industry. And we got a lot of feedback, not as much as we had hoped, but I think it was a little too broad. And so the next rounds over the next, actually in December, we will be putting out a ConOps, concept of operations document that will lay out at a very top level kind of what we are envisioning NASA, what services on a commercial destination would look like, how we think training would happen, how we think planning is going to happen, where we think the touch points are between industry and where we think the interfaces are. What we want to make super clear is we think that's your responsibility, and where we think that we need joint operations. Again, that's going to be draft. This is really difficult because to get all those things out early to you, I also get NASA to agree to let me put out drafts that aren't like fully everybody and their mother has decided that right. But we think it's really important. And so we set up a process to do that. We're not committing, but we're person to that, but we really want to iterate. And the next big item that's coming out will be another update to what the agencies put out in 2018 utilization. So what do you think is so what that we're going to need to we work really hard with the user community to identify what they think they're going to need. Everybody knows Decatur has really come out to next year, so that's another complex problem. But we do have some good we've sold together specifically on what are those minimum capabilities that we're going to need. Like, we're definitely going to need the science floor. We're definitely going to need something like this. And then what are the maybe one-offs that we're still trading. And if I gave you this list of items, is that already in your plan? Do you have other researchers and scientists that want the same things? Or is this something only NASA wants and only, other government agencies would ever use? And that gives me some feedback, because I'm going to have to prioritize, as you mentioned, many of you, no one is at least in inception is planning to have a station as big as the ISS, right? And so it's unrealistic that we're going to get everything we have on ISS on day one, and it's going to be an evolutionary process. So those two things we're really hoping can help nail down where I put it to my folks on this ConUps. We're making sure, we're in the same university. We may not be in the same class yet, right? But we're at least, in the same city, we're in the same university, and we're getting close to maybe being in the same class. And then the next round, and that will inform our requirements, which we're working very hard on, that I am expecting to come out the following quarter. So by March of the next year. We are also looking, based on your suggestion, others that we've heard from, that maybe we parse out that requirements where I can send, maybe I just put out the ECLS requirements, and maybe I just, I can break that up into pieces that will help at least get more to industry sooner. So just a little, so I'm sorry I got on my soapbox there, but I did want to make it clear that that is absolutely the approach that we're planning to do. And I appreciate you giving me the opportunity to talk about it. So with that, I'm going to hand it over to Brent. And you want me to remind you the question?
No, I'm fine. So Angela knew what was going to happen when she brought all of us up here in public. But I definitely want folks to appreciate the challenge that the agency is facing with this. So imagine you have a world-class laboratory that's been operating for decades with international partners, and all of the way that works. And it's an integrated laboratory. So the things that you need to do microgravity research, Angela just mentioned a glove box, there's freezers and furnaces and all of that equipment. Now we're facing into a future where NASA would like to not just be one of many customers, but also get its services from multiple stations. So who gets the furnace? Who gets the freezer? Do they have to be in the same lab or do they not? And if NASA allocates a couple of astronauts continuously, are they both on the same station or are they on how does that all work? And the honest answer is that we don't know yet. Nobody knows. And we're all trying to figure this out together. So I wouldn't say that's a thing that has to change, but it's a challenge that we're all, trying to deal with. Another one is that is really important. It goes sort of to Mary Lynn's point about the timing, is the timing of money. So this program is structured by analogy to commercial crew and commercial cargo, but there's a couple of very key differences. One is that when commercial crew and commercial cargo were developed, those contracts had a very healthy mix of what we call skin in the game. That means corporate money, corporate investment, and NASA funding together during the development phase to fund the non-recurring engineering to get those systems developed and tested and able to operate. The budget that Angela has for phase one of CDFF in our cases is basically 0.1% of what it costs to develop the International Space Station, 0.1%, right? So there's a big gap. And if the so-called big money comes later in the decade, then basically this plan is expecting private investors to come up with all of the money to do all of the NRE so that NASA can then contract for services on a finished product. That's a really tough putt for developing a very complex human-rated and operating space system. So we're kind of in new territory as a community to do this. That's why, as Mary Lynn said, we're all out there trying to find who are these other markets and who's willing to make an advanced services payment commitment, and where does that money come from? And when you go into the investment community, how do you explain that it's a good investment to a potential investor when you're not sure if you're going to be selected a half a decade later, but you still got to develop all the hardware now. So the return's delayed and it's uncertain, right? So, investment capital is spooked by uncertainty, and we're full of uncertainty in this program. So I just want everybody to be aware that although, we have fantastic visions, we're all committed, we're very excited about it. There's a lot of steps that we all have to get through together to make this work. And let's not forget, at the end of all that, what we're trying to do is make sure that we don't have a gap in American Western presence in LEO with humans by the time the station is decommissioned, right? In today's world, we have a new geopolitical environment. In some ways, it's like what we had in the 60s, but it is imperative that this nation not be absent human spaceflight in orbit by the end of this decade. So that's a complicated problem. You guys like complicated problems. You're getting into the right field. This is a hard one.
I think,
I'm not gonna touch that one with the tempo pool
Yeah.
yet, so I'm gonna let Marshall go ahead and maybe
Yeah,
talk
I
about that
think-
one later.
Mary Lynn and Brent both said exactly what I would have said. I got to tell you that when we look at this, like I said, we've been working on the ISS for 13 years, I said earlier. But NASA has all these requirements they want to come out with. And we have to build a space station that will last for 20 years. And let's say NASA has a requirement experiment. They want to take up 10% of the rack space with some experiment that nobody else wants to do or has capabilities, or we have to build in facilities that nobody wants to do. That's going to be really tough. So we have to try to find the common denominator in what our customers want, our potential customers, including NASA. NASA is a customer. How do we pull those things together? And so the conversations that Angela pulled up about how do we go do that? How do we figure out what makes sense and what doesn't make sense to go do are going to be really key. And the other part of that is corollary to what Brent was pulling on is the funding. The funding is not really very robust at the beginning, obviously. And therefore, we have to really lean toward what is our customer base that are bringing literally 85–90% of the funding to the table. What do they need? What do they want? At least at this point in time. I think those are really key things that we need to work through as we move forward. And how do we do what NASA needs as well as what's good for American industry to deal with the very last thing that you are going to touch, but I will. We need to keep this presence, and just to say we're going to do it or to write a paper and give it to Congress doesn't do it. In my opinion, we got to put our money where our mouth is, because as everybody knows, the economy is not what it was when we started this program. When these solicitations went out, the economy is very, very much different. Investments are drying up. If not dried up in the public-private markets, IPOs have gone down by a factor of 90%. So these are all things that make investors extremely skittish to go get engaged in this process. They love it. It sounds great. They're all in until you say, okay, who's first to put their dollar down? That's when it becomes tough.
Okay, well, with that, I'm going to switch gears a little bit because I do want to leave some time for the audience to ask questions. So I would like to just ask you, since the Von Braun theme of making space at the table, what is your organization doing, or how does your vision contribute to increasing collaboration and diversity in LEO? And I don't know, Brent, you want to start with?
Sure. Well, a couple of things come to mind. The Orbital Reef is a partnership, and we have Blue Origin is partnered with Sierra Space, and we have several very experienced teammates, including Boeing and Amazon and some others. One of those partners is Arizona State University, who have assembled an international consortium of 16 universities that do work, are expert in microgravity research. And so that provides both a sort of a front door for the global science community that want to come do research on Orbital Reef, but also to provide assistance for those who aren't already doing research but would like to. So That's the research version of the same theme I talked about earlier about lowering the bar for access. So the business architecture, the technical architecture, and the research consortium are all about pulling in as many potential users or occupants, tenants, users of space as possible. Because we know that LEO is the basis of everything else that we want to do. So the world needs to be using Earth orbit and needs to normalize being in Earth orbit as part of modern society. And that means nations that aren't yet spacefaring nations and universities that don't do research in space, and businesses that don't even think of themselves as having an interest in space. We have to do everything possible as a community to pull those in and sweep that together, because that is the market basis for all these investments and things that we want to do.
Yeah, I'll second that. And, I look at Starlab. Starlab is a US-led global effort. We are making very concentrated efforts on having international partnership. We've had multiple conferences, users conferences, if you will, to try to bring people in to say, how do you want to go use Starlab? How do you want the GWC to work? How do you want, what kind of experiments? We've done this in the US as well as internationally. So we're really trying to focus on trying to build those needs and build the collaboration and focus in on people that haven't normally had access to flight. Some people like to say ISS is a club. If you're not one of the five, the five founding members, you might get to fly if somebody's willing to give up their seat, or you might get to do an experiment if you can, afford the time and the effort to go through the process. Our goal is to make it much more accessible to countries that have not traditionally had those capabilities. We signed about 6 MOUs with Latin American countries. That was our first area of focus. We're going to be moving around to other parts of the globe, trying to bring in and help encourage those underdeveloped space nations, and maybe not underdeveloped nations, but underdeveloped space nations, to bring them into the fold, to bring them into, so they can see how space can affect their industry, how it can affect their capability to become a major player in certain areas of their business. So, we're just a collection of innovators. We're trying to, we've done some innovation in the past, but by getting on and creating a commercial market on the ISS, we want to do that with different aspects of bringing that to space industry and bringing that all together and using that diversity for a good, if you will.
Mary Lynn?
So I'd answer the question two ways. I think one of the ways that's been talked about already is geographical diversity. I'm thinking of the keynote speaker last night. For those of you that were able to attend the Von Braun dinner, she talked about both geographical diversity and generational diversity. And that's actually how I'm going to answer the question, because I think it's a very nice framing. One of them is has already been touched on here. When you provide infrastructure in space, you actually are giving countries who have not engaged in this kind of work before a way to bootstrap their own programs. Essentially, they come to the table as customers. And so Axiom is looking at, we actually already are offering sort of different tiers of participation. So for example, we've signed an MOU with New Zealand that's focused largely on their R&D organizations. They're interested in trying to fly research, right? So how it is that they would do that? Through the PAM missions, we can actually give some folks entree to that pretty early, but not, but later on, that would happen through station. So we're looking at sort of different tiers of ways of doing this, where essentially those countries can leverage infrastructure that's being provided to them for a cost. But that's a way to sort of expand that geographical diversity. And I think everyone's, sort of thinking about this the same way. But the other one I really want to pull on is generational diversity. We're in trouble in this country in aerospace with regard to workforce. We're in big trouble. I don't know how many open recs you guys have on your websites. Okay, but we've got about 200. I talked to other companies and they're running between 200 and 500. So what is happening across aerospace is that there is sort of an effort. There was a recent announcement of something like this from the Biden administration, but it was not just those companies. But the companies here are participating, but it's not just those companies. Axiom's working through community colleges, and we're actually going down another level to high schools now. And sort of reaching out to high schools, because the message that we're giving them is, there's a lot of room for an awful lot of interests and a lot of skills okay, that are not traditional aerospace skills, the way you would think about those, are going to be involved in like flying these space stations, right? And not just sort of the operations of the stations, but the development of the stations and then the uses of the stations, which is really left to your imagination. If you can, team up with a university or join with a consortium or enter into an institute or become an entrepreneur, or I mean, there's multiple paths now when I think about how I came into this. It's very different. And so really starting to reach out to those students younger and younger, which also has the opportunity for us to try and help shape that STEM pipeline, STEAM pipeline that we are all so dependent upon, and which is reaching crisis proportions in this country with regard to sort of availability of workforce. And so really focusing on generational diversity. And I think this avenue of, commercial LEO destinations, as well as other ways that sort of the whole space endeavor of the whole enterprise is opening up to new approaches, gives us the opportunity to do that. But it takes a very concerted, very thoughtful, very systematic, and very committed approach to doing it. It's not something we can hit and come back to 6 months from now and come back to 2 years from now. It's something that we have to work on very, very consistently to build that pipeline.
So I have some follow-ons questions that I can do, but if we're ready for audience questions, I can be ready, or I can do one more.
We'll go to Jeff.
I wanted to follow up on something that Marshall brought up, and that is the investment climate right now. I was at a conference earlier this week where a lot of the people in the investment community were very concerned about being able to find investment for high capital expenditure, high CapEx projects, and commercial space stations certainly seem like a high CapEx project. In the market, do you see any concerns about being able to raise the funding that you need to develop these space stations? Is there anything that NASA can do short of providing more funding to help make it easier for you to raise that private investment?
Yeah, that's a great question. Actually, I was discussing that question with Angela yesterday. But, certainly it's tighter. And, we are working, and as I'm sure everybody is working here with folks to get them willing to invest, ready to go, ready to invest. And I think that's very important. There are people out there that are willing to do it. They're just being a little bit more tight-fisted about it, if you will, and for understandable reasons. But I think what NASA can do is, probably put more down, because, you talk to an investor and they say, well, NASA's giving you 5% right now. Is more money going to come later? Why would I put down 80% or 60% or whatever they're going to put in, or 20% of what you need? And I think NASA putting more funding in early would be helpful. It would be a signal, a actual concrete signal, rather than just a statement of we're going to do this, that the government is much more ready to engage in this. And that would probably give investors more confidence. That would be the one thing I would say that would be the most concrete. Obviously, we need NASA to continue to be public about their intents, what they're going to go do, why they're doing it, that this is really going to happen. I think all of those things are real important, but nothing speaks like money.
I guess my angle on that would be the money NASA has is the money NASA has because it has the budget it has, and it's trying to do a lot of things, one of which is still operate and use the space station we have. And so there's a carrying cost of that program, which is, we call it a wedge in the budget. And until that wedge diminishes, there isn't, it's hard to know where to get other money to put down. But I think there may be some creative ways that together we can provide more surety in the marketplace. And I would argue it's not so much the cash on the barrelhead as it is the commitment that represents assurance for a potential investor. Anybody who's going to invest in this business knows that that is a long-term investment. You're not going to make your money back in a couple of years, which is sort of the typical horizon for high-tech investors. So I'll just make one up and say, for example, the idea of a promissory note, you could call it, for assured purchase of services years in the future, right? That doesn't mean cash now, today, but it means a commitment. Now, that's hard for the agency because of the way the agency is funded and the Anti-Deficiency Act and all, this is very tough for the government to do. But I think we need to be creative about ways to enable investors to feel confident about the government participation in this multi-party market years from now. It's those types of signals that even a spooked investment community will start to pay attention to.
And I would want to follow on to that. I totally agree with you. NASA's budget has been set. It's been set for years. It's very difficult to change. I bring my statements up in that I hope that our nation and Congress see the need for doing this because
And the
of what we're doing
urgency.
and the urgency for doing it now, particularly with things that have happened of late in the international landscape. And Congress can do something about that. They can appropriate more money if it's of national importance. And that's why I bring up, I think that NASA through that process, if Congress so chooses to do so, could actually help the investment community. And then if they did, then obviously we also have to be creative. I think that's an interesting idea. I'm not sure how that works, but it would be good.
I have no idea how it works.
So I guess it would differ a little bit. So from Axiom's point of view, we're not pursuing additional funding from the government until the point the government is laying out these services contracts that it's talking about doing. But this does go back to what I said earlier about a better understanding of what the requirements are. There are some real differences between the way this is the situation, the context in which this program is occurring from the COTS program, the CRS, what became CRS and Commercial Crew. And that was that you had a very well understood, essentially traffic model back and forth to the ISS. And that traffic model was understood before this program started. We've been flying shuttle for a long time. And so we had a sense of what we were going to need in terms of cargo delivery and crew delivery. The cadence might change. We weren't going to be doing the same kind of building that we were doing on the ISS, but you did understand pretty broadly what was needed in terms of resupply, what you were going to be looking for in terms of crew cadres and increments and all the rest of that. And that was well understood. That's not the case here. Those requirements have not been laid out. We understand the difficulty of the problem. I appreciate everything that you said about the approach that you're taking, but it's a very different case. And the other thing that's very different is that we have a competitor sitting in low Earth orbit. And this is no kidding. Okay. The reason I came out of my semi-retirement and joined Axiom. Okay. It is really a real challenge that we're facing, that competition. And so how do we go about doing this? Well, everything that I agree with what my colleagues have said, except that we're not seeking additional funding at this point. We are going to the markets. Okay. We are finding that we can have conversations with investors, okay, about that going forward. But this is a real concern because we can't get to the point where we are facing that gap. We just can't get to that point where we're facing that gap. Gaps have a way of perpetuating themselves. People are incentivized to continue gaps, okay, after a period of time when the sky doesn't fall, okay, but there's a real concern there because the geopolitical consideration is very different now.
We can hear you. Go
All
ahead.
right.
Keep talking.
There you go. That's
Okay,
better.
All right. Yeah, that's way better.
Yeah, we really.
All right.
can.
So I was saying, good afternoon. My name is Tushoma. I'm from Embry-Riddle Aeronautical University. I wanted to thank everybody on the panel for giving a presentation on the commercialization of low Earth orbit vehicles or stations. So my question is, although the development of commercial low Earth orbit station is a new market, will the international traffic arms regulations affect foreign customers to use the stations compared to domestic customers?
Oh, so let me just jump in. There's two aspects to that are really interesting. One is that the program we have today flying, the International Space Station, has a kind of umbrella waiver for ITAR considerations. It's got a special exemption that if you're in the space station program or you're participating in it, the ITAR barriers are much reduced compared to other kinds of aerospace programs. We don't have that for our commercial station developments, and we could use it. The other, which you actually asked, is about people using a station, and that's a really interesting question. I think that touches on a whole set of issues that are unresolved as of yet about kind of the comprehensive regulatory environment, as well as even maybe more mundane things like the onboard jurisdiction. Like who controls what? Is it, captain's rules, or is it something else? And when you have international participants or visitors, what is the legal regime that actually operates on that station when it's flying all around the planet, every 90 minutes? The world we have lived in so far, or that we are still in, is one in which the activities of actors in space are accountable by the launching state, right? That's Article 6 in the Outer Space Treaty. But these permanent destinations like the International Space Station or the Chinese space station or former Russian space stations are national assets. That's not what we're talking about here. So this is new territory, and all of those things have to be worked out. That's yet another thing that is kind of pressing on calendar, to Mary Lynn's point about, this looming gap. We got to work all these things out in the time we have.
Well, thank you. I heard that was the last question. I think we're over our time. I want to thank the participants and the panels. Please give them a round of thank you. They were very